right, hi guys. I'm so sorry I am not here today. I'm at a conference, so we are just wrapping up the rest of our notes today. The notes are talking about climate change and ocean acidification. So let's go through these together.
More trucks, more trucks. You find more trucks at local truck depot.
Two frogs are minding their own business in the swamp when, wham, they're kidnapped. They come to in a kitchen, captives of a menacing chef. He boils up a pot of water and lobs one of the frogs in, but it's having none of this. The second its toes hit the scalding water, it jumps right out the window. The chef refills the pot, but this time he doesn't turn on the heat. He plops the second frog in, and this frog's okay with that. The chef turns the heat on very low, and the temperature of the water slowly rises. So slowly that the frog doesn't notice. In fact, it basks in the balmy water. Only when the surface begins to bubble does the frog realize it's toast. What's funny about this parable is that it's not scientifically true for frogs. In reality, a frog will detect slowly heating water and leap to safety. Humans, on the other hand, are a different story. We're perfectly happy to sit in the pot and slowly turn up the heat, all the while insisting it isn't our hand on the dial, arguing about whether we can trust thermometers and questioning, even if they're right, does it matter? It does. Since 1850, global average temperatures have risen by 1 degree Celsius. That may not sound like a lot, but it is. Why? 1 degree is an average. Many places have already gotten much warmer than that. Some places in the Arctic have already warmed 4 degrees. If global average temperatures increase 1 more degree, the coldest nights in the Arctic might get 10 degrees warmer. The warmest days in Mumbai might get 5 degrees hotter. So how did we get here? Almost everything that makes modern life possible relies on fossil fuels. Coal, oil, and gas, full of carbon from ancient organic matter. When we burn fossil fuels, we release carbon dioxide that builds up in our atmosphere, where it remains for hundreds or even thousands of years, letting heat in, but not out. The heat comes from sunlight, which passes through the atmosphere to Earth, where it gets absorbed and warms everything up. Warm objects emit infrared radiation, which should pass back out into space, because most atmospheric gases don't absorb it. But greenhouse gases, carbon dioxide and methane, do absorb infrared wavelengths. So when we add more of those gases to the atmosphere, less heat makes it back out to space, and our planet warms up. If we keep emitting greenhouse gases at our current pace, scientists predict temperatures will rise 4 degrees from their pre-industrial levels by 2100. They've identified 1.5 degrees of warming, global averages half a degree warmer than today's, as a threshold beyond which the negative impacts of climate change will become increasingly severe. To keep from crossing that threshold, we need to get our greenhouse gas emissions down to zero as fast as possible. Or rather, we have to get emissions down to what's called net zero, meaning we may still be putting some greenhouse gases into the atmosphere, but we take out as much as we put in. This doesn't mean we can just keep emitting and sequester all that carbon. We couldn't keep up with our emissions through natural methods, and technological solutions would be prohibitively expensive and require huge amounts of permanent storage. Instead, while we switch from coal, oil, and natural gas to clean energy and fuels, which will take time, we can mitigate the damage by removing carbon from the atmosphere. Jumping out of the proverbial pot isn't an option, but we can do something the frogs can't. Reach over and turn down the heat. Can you guess one surprising puzzle we need to solve to run our planet on?
All right, so going along with that, let's talk about it. So what is climate change? Climate change is the warming of our Earth. So the Earth has undergone climate change through geological time, with major shifts in global temperature causing periods of warming and cooling as recorded with CO2 data and ice cores. However, the current period of warming is occurring more rapidly than in the past events. So the biggest thing that a lot of people will talk about if they don't believe in climate change is like, oh, in different times we've seen temperatures fluctuate. And we're like, yes, that is true, but we've never seen temperatures fluctuate at such a drastic measure. They are getting a lot worse, a lot quicker. So like the video said, scientists are concerned that natural fluctuations in the climate are being overtaken by rapid human-inducing warming that has serious implications for the stability of the planet's climate. So not only is it happening, but a lot of people are like, oh, it's not humans, but realistically it is humans. Humans are the ones that are creating this environment because of the technologies that we are using. So 5 questions of climate science. 1, is current climate change real? 2, have humans caused it? 3, what is projected climate change? 4, what are the impacts of climate change? And 5, what do we do about it? So the very first question is climate change real? So we know that for 150 years that carbon dioxide is a greenhouse gas. We talked about greenhouse gases on Monday, and knowing that a greenhouse gas's job is to reflect the heat from the sun to incubate our earth is important because, like we said, that is necessary for our earth to be habitable, to be able to do that. And then have humans cause climate change. So by creating the CO2 that's being put into the atmosphere, you're making more of a greenhouse gas. So Intergovernmental Panel on Climate Change, or IPCC, said that we definitely have discernible human influence on climate, that it's warming the world. In 2007, it said that it's evident from observations that it's coming from humans, and that the warming of the climate system is unequivocal. Observed changes are unprecedented. So we're looking at this situation and seeing that not only is it happening, but it's happening at an alarming rate. So if you look at NAS, or the National Academy of Science, you'll see that global annual averages of surface air temperature have increased about 1.8 degrees Fahrenheit or 1 degree Celsius over the last 115 years. This period is now the warmest in the history of modern civilization. So for us here, so you look down here at this beautiful graph, that it's the warmest we've ever been since humans have been on the earth, which is crazy. It is extremely likely that human activities, especially emissions of greenhouse gases, are the dominant cause of observed warming since the mid-20th century. So climate change is definitely real, and humans have definitely caused climate change. So you can see the measurable changes in values, the global average sea level change. We'll talk about ocean acidification and ocean warming. Average upper ocean heat, northern hemisphere spring snow cover. We know this more than anything else, that our snow cover is going down. Arctic summer sea ice extent, the Arctic ice is going down as well. So we're seeing this actually happening. So what is causing this? If we look at this, the number one thing that is causing it is fossil fuel emissions. So I'm highlighting in blue what you should be taking notes on. So we are actively adding greenhouse gases, which increase the greenhouse effect and produces warming. That is what we are doing on the daily. On top of that, we are adding atmospheric aerosols. So by adding that, we are adding soot, smog, smoke, and it changes albedo, or like the fluctuation of temperature. And then land changes, disrupting natural vegetation. So we talked about urban heat islands when we talked about urbanization, how in a city it is noticeably warmer, that if you go to Salt Lake City, it is going to be noticeably warmer than Lehigh because of the urbanization, because of the cement, because of the lack of trees and the lack of vegetation. That changes the temperature. So one of the things other than greenhouse gases is the fact that we are changing the environment that we're living in and changing it to cement and concrete. That is causing a big problem for our environment. So what is projected climate change? So projected climate change is showing, this is worst case scenario right here. This is medium case scenario. This is the trajectory we're on. And this is best case scenario. So like I said, the top one, RC 8.5 is uncontrolled emissions show warming of 3 to 3.5 Celsius by 2100. 2.6, which is the very bottom one, or the best case scenario, is showing the eliminating of emissions show a warming of only 0.25 to 1.75 by 2100. So this is eliminating emissions, which is not going to happen. There's no way we're going to eliminate total emissions across the globe. But if we are diligent, if we try, so the light blue line, we can do better. So if we look right here, no climate policies, like it said, would lead us right here. If we did a ton of stuff, we could get down to 1.5. That's very not likely. Current policies is going to have us at 2.7 to 3.1 degrees Celsius by 2100, which is a lot. Pledges and targets have us at 2.4. So, I mean, we're still going to be hotter than we really need to be. Like, we're still going to see drastic changes because of what we have done, but hopefully we can mitigate them a little bit more. So warming is not uniform. It's the most severe over land in the northern hemisphere and at higher latitudes. So when people talk about the fact that global warming is only 1 degree Celsius, it is a 1 degree average, which means that there's different places in the earth that are being hit a lot harder than other places. So like I said, it's northern hemisphere, which is us, and at high latitudes, which means at the poles. So the poles are being hit the hardest, which is a huge problem because that's where we have all of the ice caps. And the ice caps are going to start melting and affecting ocean levels and the availability of fresh water. So changes in precipitation is not uniform. It is most severe in the tropics and the poles. Areas of drying include U.S. Southwest, the Amazon, the Mediterranean, etc. So you can see that, like, in Utah, we're okay. Nothing's big changing. But if you look in South America, like the southern hemisphere, you can see that the average precipitation is going down. That we're seeing a lot of drying out in areas like the Amazon and the Mediterranean where they're usually humid. So what are the impacts of climate change? We've learned about Hadley cells before. So it will affect the winds. So as temperatures change, that may impact the Hadley cells. So it may impact how we see El Nino and La Nina happening. It could impact how we see ecosystems and the amount of rain and moisture we get in certain areas because of the changing of the winds. So poleward expansion of the Hadley cells expands dry climate belts around the globe. So we expect to see more dryness around the globe. And then when it shifts the jet streams, it'll push storm tracks further. It will push storm tracks farther north and south and change precipitation patterns. So we're going to see drying out of areas and lots of rain and stuff in areas that don't usually get it, or areas that are usually colder, which is going to make a big deal. It also really impacts the ocean. So the ocean conveyor belt carries heat through the world. When these currents change, it can have a big impact on global climate. On top of that, warming temperatures result in weakened currents and promote stratification, or more defined layering in the ocean. So the problem with that is that it reduces the transfer of dissolved compounds such as oxygen and carbon dioxide. So the circulating of nutrients in the water are going to slow down, and that's going to impact our aquatic ecosystems. Not only that, but we're going to have habitat loss. We are going to alter where species range, the interactions, and the timing of biological events. we're going to see a lot of extinctions happening because of this. Because of climate change, species behaviors are going to change, and that is going to have a big impact on all other species that depend on them. And so we're going to see interactions, ranges, extinctions. We already have seen a big change in range. So there is a type of bear called a growler bear, and it is a mix between a grizzly and a polar. Because polar bears have started making their way down from the poles because of ice melting, and they have changed enough that they can breed with grizzlies and create a viable offspring, which means that we may see the extinction of the grizzly bear and the extinction of the polar bear and the bringing in of a new species called the growler bear because of this, which is absolutely crazy. So you can see that sea level is rising and how it's affecting the population. So projected sea level rise by 2100. So highest projection means that 7.8 million people will be impacted. Intermediate high projection means 4.7 million people will be impacted. Intermediate low projection, so this is like best case scenario at the moment, is 1.8 million people are going to be impacted. And then the lowest projection, which we probably aren't going to hit because that is like pie in the sky, everything goes well, we're going to have 1.3 million people impacted, which is absolutely crazy. So Earth's polar regions are showing a faster response time to global changes because of ice and snow in these regions normally reflect most energy back into space, leading for a positive feedback loop. So what this is saying is that the ice caps right here, they usually reflect the sun off of them, which keeps the temperature colder. However, when the ice caps start to melt, we're going to have less of this area that is going to be able to reflect the light, which means that we are going to have a bigger impact and it's going to get warmer quicker. So let's see what I want you to write down. I want you to write down this whole thing. So Earth's polar regions are showing faster response times to global climate change because ice and snow in these regions normally reflect the most energy back to the space, leading to a positive loop. As the Earth warms, the ice and snow melts, meaning less solar energy is radiated back into space and instead is absorbed by Earth's surface, meaning that it is going to get warmer quicker. So for my visual friends, this is what it looks like. So atmospheric temperature rises, the snow and ice melts, which changes the surface albedo, which means that it's going to get warmer and get warmer. And so we're seeing this positive feedback loop where the melting of the snow and ice makes things warmer, which melts more snow and ice, which makes things warmer, and you kind of get out of control. So what do we do about it? So we have our international panel on climate change, which investigates and reports on scientific evidence on climate change and possible international responses to climate change. So IPCC is International Panel on Climate Change, investigates for the international thing. We have the United Nations Framework Convention on Climate Change, or UNFCCC. In 1991, it was signed by 166 nations. It did not contain any specific national or international targets to reduce greenhouse gases, but it doesn't contain key points or principles that have guided international climate change debates and processes. So this panel actually has a goal. This one is a convention, so it's like talking about it. It's not quite as important, but it does get in the conversation. We have Conference of Parties meeting in Kyoto, Japan, which created the Kyoto Protocol. This one is actually really important. So the Kyoto Protocol established developed countries' emission targets for 2008 to 2012. So Kyoto Protocol actually did something. So International Panel of Climate Change investigates and reports what's happening internationally. The United Nations Framework just talks about things. The Conference of Parties, or the COP, created the Kyoto Protocol, which actually put something into action. We actually had emissions targets. So COP also met in Copenhagen in 2009, Cancun in 2010, and Durban in 2011, when negotiations were ongoing for establishing legally binding treaty for post-2012 climate and further commitment periods from the Kyoto Protocol. This led to the Green Climate Fund, the Technology Mechanism, the Cancun Adaptation Framework, and the Forest Management Reference Levels. So all of these things came from COP. So COP is actually really, really important, understanding that this conference that is held in different places. So the first conference was held in Kyoto, then in Copenhagen, then in Cancun, then in Durban. Each of them led to some kind of actionable item that we could do, which is awesome. Next, we have the Paris Agreement. The Paris Agreement is an agreement within the United Nations Framework Convention on Climate Change, dealing with greenhouse gas emission mitigation, adaptation, and finance starting in the year 2020. The Paris Agreement long-term goal is to keep the increasing global average temperature to well below 2 degrees Celsius above pre-industrial levels and to limit the increase to 1.5 degrees Celsius since this would substantially reduce the risk of effects of climate change. So this is awesome. This is something that is happening, going on right now, the Paris Agreement. A lot of countries are working on this. Something really interesting to learn or to know is that in 2020, when President Trump was the leader of our nation, he pulled us from the Paris Agreement, which means that we did not have to follow this. And it wasn't until President Biden came into power that we rejoined the Paris Agreement. And so now with elections going on, like the ability and the priority of the United States to do what it can to help climate change is kind of in the balance, because depending on who is leading our nation and their beliefs on climate change, it can really affect what we are doing and how we can actually move forward. So what do we do about climate change? Number one, speak up. The more you know, the more you say, the more education people have, the bigger the change we can have. Power your home with renewable energy. So do what you can. Figure out what renewable energy speaks to you and go for it. Drive less. I love driving less. Trip chunk, carpool, use public transportation, walk when you can. Do whatever you can to drive less, because that is going to make a huge difference. Invest in energy efficient appliances. You guys are in high school right now, but when you have the chance to build your own home, try to get appliances that use low energy, low cost. Get smart thermostats and smart devices that will help you be aware of the amount of energy that you are actually using. Because the less energy we use, the less of an impact we will make. Reduce water waste. I cannot stress this enough. In Utah, some people think that we have to have grass and it has to be green. There are places that have grass that no one is actually using the grass. It is just there to look pretty, which is the most asinine thing I have ever seen in my life. That we are using drinkable water to put on grass that no one is using, when we could have just put rocks down, or we could have put water-tolerant plants down, or we could have done a myriad of other things. So figuring out how to reduce your water waste. This also could be taking shorter showers. You do not need to take a shower longer than 5 minutes. Like, truthfully, get in, wash your body, wash your hair, wash your face, shave if you need to, and then get out. Like, there is no reason for you to be in there for longer than 5 minutes. Actually eat the food you buy and make less of it meat. Food waste is a huge problem in the United States. A family of 4 spends about $1,000 a year on food that is never eaten, that is thrown away. And so if we can eat less food, or waste less food and eat less meat, we will have a much bigger impact by not wasting the water and the fossil fuels to get the food to our table in the first place. And then we also know that cows are a big, huge emitter of greenhouse gases. And so understanding that and making sure that we are using less red meat. I'm not saying go vegetarian. I am not a vegetarian. But the less red meat we can use, the better it's going to be. Buy better bulbs. So use energy efficient. Like, there are so many better bulbs out there that use so much less energy. And then pull the plugs. If something is not being used, it does not need to be plugged in. Even when something is not being used and it's plugged in, it is still pulling energy. And so by unplugging things, you can actually save a lot of energy. Or you can use a power strip. A power strip is a really cool way of keeping things plugged in without using more energy. I'm going to skip past these. If you'd like to watch these videos, you can, or I'll show them on a review day. This is talking about self-healing concrete, which is so, so cool. And then this video talks about the good news that is coming from climate change. In an effort to make sure that this video isn't super freaking long, I'm going to skip past that. So, ocean warming, like we've talked about before, that because of the ice caps melting and because of global warming, we are seeing ocean warming as well, which is hard for those that are living on the coastal areas because they're going to have to move more inward. So it's affecting ecosystems in different ways. So what's the issue? Like we already talked about before, it's greenhouse gases. Greenhouse gases are creating the warmer temperature in the atmosphere, in the world, and so we are seeing a big change in the amount of water and the temperature of the water. We can see that the ocean has absorbed more than 93% of the excess heat from greenhouse gases. So even though we're feeling the heat temperature change on land, the ocean is taking the biggest burden because the ocean absorbs the majority of the heat. So that shows that the average global sea surface temperature has increased approximately 1.3 degrees Celsius per decade over the past 100 years. So if you look at that, you can see that we have a very uptrend of the ocean temperatures, which is so problematic. So what is the issue? Is that the ocean's ability to absorb excess heat has shielded humans from even more rapid changes in climate. Without this ocean buffer, global temperatures would have risen much more than they have in the past. IPCC's fourth assessment report published in 2007 estimated that the Earth has experienced a warming of 0.55 degrees Celsius since the 1970s. So every single year, we have had that temperature rise. If the oceans had not absorbed the direct heat, it would have been a lot worse. It says that between 1955 and 2010, the energy had remained lower than 10 kilometers of the atmosphere. The Earth would have seen a warming of 36 degrees Celsius. That if we didn't have the ocean, we wouldn't have just raised 1 degree Celsius. It would have been 36 degrees Celsius. So the ocean is a super homie taking care of us, and we need to be aware of this. So what do we do? What can we do? So warm water holds oxygen less. This is something I have tried to pound into your head since the very beginning. Cold water holds oxygen better. Warm water holds oxygen less. So we have less oxygen in our waters, and the sea level is rising, which is causing a bunch of problems. On top of that, it is continually melting the ice, which is making the sea level rise, and it's a positive feedback loop again. So the warmer the water gets, the more the ice is going to melt. The more the ice is going to melt, the more the water is going to rise, and then so on and so forth. It also impacts marine species and ecosystems, and it can change the morality and increase the spread of diseases, loss of breeding grounds, and mass movement of animals from their environment. And it also can create coral bleaching, which is basically the killing of the coral, which is not good because coral is literally the lifeblood of the ocean. So this is showing what healthy coral looks like, bleached coral and dead coral. Impacts of coral bleaching is that it has a big impact on coral communities, fish communities, and human communities. So it affects us a lot more than we like to think. The ocean is a carbon sink, which means that it absorbs a lot of our carbon from the atmosphere. And the warmer it gets, it can't do this job quite as much. And so that extra CO2 that is being absorbed from the atmosphere is making the ocean acidic. That acidity is actually dissolving the animals that are living in the ocean, which is so, so sad. So why do we care? We already talked about people being misplaced because of the ocean rising, the animals being moved from their places, and the fact that people take about 15% of their animal protein from the ocean. And so when we see this, it's going to affect the feeding of the world. So what can be done? Limiting greenhouse gas emissions, protecting marine and coastal ecosystems, restoring marine and coastal ecosystems itself, and then strengthening scientific research. So that is the end of these notes. I will post the notes on Canvas so you can take notes as you can go back and get the notes that you would like. But hopefully this is helpful and be ready to review for next time.